Hey people, this is my first project introduction video, and this one is going to be for my drone project, which has been ongoing for a while. I haven't done anything on it recently though, but I intend to do so. So this is the drone in its physical self. It is 3D printed in pure PLA because I don't have an enclosure to print ABS. I don't want the fumes and stuff. As you can see, it is, instead of quadcopter, it's single centered, well, dual centered motors in a ducted fan kind of style with, I'm not sure if I actually have any of the, well, I got one. I mean, these are just preliminary because I haven't gone to testing, so they're mostly for show. Little fins which goes on the servos in the bottom here. And see, so the idea is to basically have the control with the servos instead of differential thrust, which is what you use on a normal quadcopter. I'm probably gonna make those bigger for, well, more torque. But we'll see how it goes once I actually get running. I've tested the actual motors in the build, and it's got a thrust to weight ratio that is very low for a drone, about 1.5 or something like that. So I'm gonna have to make a lighter version if I want to do anything real. I think I can get this to fly, not very well, but I think I can get to fly. Anyhow, as I said, two 1 kV motors with 10-inch propellers. That's about 25 centimeters. Yeah, 1045R. And for batteries, I am using 18650 lithium cells, which I made a little battery bank. So I've got 3 series connected batteries, so 11.1 volts for each motor. I'm not sure if this is a good or bad idea yet. Each motor having its own battery bank. I mean, if for some reason one motor breaks down, shorts out, whatever, then the other one can still run and it will crash less hard, I guess. The motors and the speed controllers here are store-bought, so to speak. They're bought on eBay. And the idea is to connect it all to a PCB I'm going to make back here. It's going to be a prototype kind of deal, which I am going to maybe get made if it actually turns out to be a viable design. But as I said, I'm probably gonna make a lighter one if this works. As for sensors, I have only one connected right now. I'm going to have 2 more. I have the MPU 9250, I believe it's called. Let's see what it says. Yeah. Basically, it's a gyro sensor, accelerometer, and magnetometer, and a temperature sensor in there. But yeah, what I'm going to use to get orientation, degrees of rotation per second, and of course altitude from. No, not of course. Of course, I'm going to have a BMP sensor down here for altitude measurement. And the magnetometer is for sensing yaw. That is pretty hard to do with only a gyro and accelerometer because it will drift. Now, as for actual the remote control side, I have had the idea to use this fella. Now, the reason I'm going to use this is because I'm not going to have to totally make a controller from scratch. You know, the whole ergonomics kind of deal. Not good at organic design, which you kind of have to be if you want to make something really ergonomic. So why not use something that is made to be hold for long periods of time? Okay, it's probably not going to be hold for long periods of time. I mean, it's the batteries I'm using has a 2500 milliamp hour capacity, so yeah, total drone is 5000 milliamp hour, but each motor has 25. See if we can get this screw here out. I'm not a fan of these security screws. Let's just see if we got another bit that'll fit. Oh, much better. Much better. Right. Some may notice I've already removed the battery clips in here. Right. That should be it, I believe. Yeah. Now the reason I want to use this is because these are just basically two potentiometers. So they're pretty easy to use, standard ones that you can buy for Arduino and stuff like that. But the throttle buttons down here are also potentiometers. Just a little mechanical arm that flips that, as opposed to, for example, our PlayStation 3 controller, which has some weird membrane, analog membrane kind of deal. This is much easier to use, so I'm basically thinking that I'm going to take a Dremel or something and filter, gas mask kind of deal, and cut out this portion of the PCB. I believe that, no, they're not. But yeah, basically everything of the PCB that I don't need, so I'm not going to need this. Of course, I need to hold the two sides together, and this is the one of the analog rockers. But the part I don't need, then pop in my own PCB that will connect to these three. Maybe I'll use all four analog controls. And then store batteries down here or something like that. At least that's the idea so far. I think it'll fit. I may use something like I got a few Arduino Nanos laying around, something like that, because space is an issue. So I'm not going to use my regular. I usually use the full dip-sized Atmega, which will not really fit in here, I think. Let's see what we got. So yeah, usually it'll get about this size, which even if I cut out the lack of necessities, I think I could get it in there actually. But I think an Arduino Nano would be easier. Yeah. Anyhow, I think that is basically all. I mean, I got a bunch of ideas for the drone that I want to do, but yeah. It's gonna be progress reports from here on. Soon, actually, because I'm working on making the electronics for the remote itself, or at least a breadboard version to see if it'll actually work. Anywho, that is all. Thank you for watching, and see you next time.